Welcome to the next video in measure theory and probability. This is video 7.1 on measurability and continuity. It corresponds to part 1, chapter 1, section 3 of the textbook. So let's jump into a theorem. Let E have a Borel sigma field, and recall what that means. The Borel sigma field necessarily means that there must be some kind of a topology on E. We're not going to focus too much on that topology, but that's what this means, is that there is some topology, some collection of open sets. And so the Borel sigma field is the sigma field that is generated by the open sets. So we've got a Borel sigma field, we've got another Borel sigma field on some other set, and we have a continuous function from E to F. Under all of these conditions, the claim is that F is measurable. Now, we will use here an earlier theorem, which allows us to employ the following technique. We will use a generating set, which is a subset of the given sigma field, in particular the one for the range. And with that generating set, we will show only that pre-images of its members are contained in the sigma field of the domain, right? So there was an earlier theorem which said that this is a sufficient condition, right? If you don't have to do it on the entire sigma field, you can just do it on a generating set for the sigma field. In this particular case, which generating set are we going to choose? Well, it should be obvious. If these things just are, by definition, generated by the associated topology, then the topology is going to be the thing that generates, right? So here we're going to set C to be the topology for F. And so when we pick an element out of this collection, we're really picking an open set, right? It just means by definition that because this is the topology, when you pick something out of it, you have an open set. Now, by the topological definition of continuous functions, the definition is that a function is continuous if the pre-image of any open set is open in the domain topology. So when we take the pre-image of this open set, we necessarily get an open set, right? That is the definition of a continuous function, is that it does that. Okay, well, because this set is open, then therefore it is in the sigma field generated by the open sets, right? If this is an open set, it is one of the generating members and necessarily is in the generated set. So there you have it, right? We just showed that the pre-image of all of these members are themselves in the domain sigma field, and that shows that F is measurable.